Have you ever wondered how everyday products like shampoos, soaps, and detergents are made? These common products that we use daily are often taken for granted, but there's a lot of chemistry and magic happening behind the scenes. One of the key processes involved in their creation is a chemical reaction known as ethoxylation. Picture ethoxylation as a meticulous dance between molecules. It's the process where ethylene oxide, a compound with a ring of carbon and oxygen atoms, gracefully attaches itself to a substrate. This substrate could be an alcohol or a phenol, both of which are organic compounds with a certain kind of functional group. The result of this dance, a new compound called an alcohol ethoxylate is born. Alcohol ethoxylates are the unsung heroes in many of our everyday products. They provide the foamy lather in our shampoos, the cleaning power in our detergents, and the silky texture in our soaps. Now you might be asking, how does this ethoxylation process actually work? The ethoxylation reaction might sound complex, but it can be broken down into 5 basic steps. It's akin to a well-choreographed dance where each move is calculated and precise, leading us to the final elegant product. Step 1 of this dance begins with the mixing of the alcohol substrate with a catalyst. Our catalyst of choice is typically potassium hydroxide or KOH, a strong base that kickstarts our reaction. Step 2 involves the addition of our star performer, ethylene oxide. This is not a haphazard addition, oh no. Ethylene oxide is added at a carefully controlled rate, ensuring the reaction proceeds smoothly and predictably. The third step is where things really heat up. The reaction is carried out at elevated temperature and pressure, typically between 130 to 180 degrees Celsius and 1 to 6 atmospheres. This is the stage where the magic happens, where the ethylene oxide reacts with the alcohol substrate to form our desired product. As with any good performance, knowing when to take a bow is crucial. In the fourth step, the reaction mixture is cooled and neutralized to halt the reaction. This is an important step as it prevents the reaction from going too far and producing unwanted byproducts. And finally, we reach the fifth and final step, the purification of the product. This can be achieved through distillation or other means, ensuring that what we're left with is pure, high-quality alcohol ethoxylate. Now, it's important to note that the ethoxylation reaction is highly exothermic. That means it releases a lot of heat. This heat must be carefully controlled to avoid what we call a thermal runaway, which could lead to an explosion. It's a delicate balance, a dangerous dance if you will, but when carried out correctly, it's a thing of beauty. The ethoxylation reaction is a delicate process, with the release of heat needing careful control to avoid any dangerous situations. But when done right, it's the secret behind many of the everyday products we use and love. So why is this ethoxylation process so important, you may ask? Well, the factors that govern the ethoxylation reaction, including the type of substrate, the amount of ethylene oxide used, the reaction temperature and pressure, the type and concentration of catalyst, and the reaction time, result in a product with fascinating properties. The product is a mixture of alcohol ethoxylates, each with a different degree of ethoxylation, which is determined by the number of ethylene oxide units added to the alcohol substrate. These alcohol ethoxylates are non-ionic surfactants, meaning they lack a net electrical charge. This unique characteristic makes them perfect for a wide range of applications. From personal care products like detergents and shampoos to industrial applications such as metal cleaning and food processing, alcohol ethoxylates play an integral part. So the next time you use your shampoo or wash your dishes, remember the magic of ethoxylation that goes into making these everyday products.